journal today, we're using 1-inch grid paper to draw some larger rectangles. Meaning we're going to be drawing rectangles that measure more than just 1 inch on each side. In fact, at the top of our journal, with a marker, we've already drawn a rectangle that measures 2 inches wide and 3.5 inches long. See where it's 3 inches and then half of another inch? I'm going to go ahead and label this 3.5 inches long. So if you're watching this journal at home, take a minute and pause the video so you can draw this first rectangle, and I'm going to go ahead and shade it in. The reason we're drawing larger rectangles today is because we need to start multiplying with mixed numbers. We've multiplied with whole numbers, we've multiplied with fractions, but we've not really talked about how we can multiply with mixed numbers. And we know that finding area requires us to use multiplication because area is length times width. We're going to be finding the area of the rectangles that we're drawing in our journal today. Okay, now I want us to think of something for a moment. I think a few days ago we actually did draw a tile that measured 2 inches wide and only 3 inches long. So if I covered up part of my rectangle and said, well, this rectangle only measures 2 inches by 3 inches, what would the area of that rectangle be? 6 square, remember we have to say square inches when we're talking about area. Where do you see the 6 square inches at, Christopher? In the box. I can literally count 1, 2, 3, 4, 5, 6 squares. That's 6 square inches. I want to use that same type of thinking today to find our area. I want you to take our marker and we're going to count as we label the area that's inside that box. I see 1 square inch. Here's another 1 square inch. Another 1 square inch. Do you see any more 1 square inches? 3 more. So 1, 1, 1. Where do you see one more at? Okay, Christopher says if you put these two pieces on the end together, it would equal 1 square inch. So what are these? These are halves. Let's label these, Miami, as halves. I know we've been talking about area all week, and we've been multiplying, because to find area, you multiply the length times the width, label your sides. But another way to find area is to literally count the square inches that are inside our figure. So let's count the area. I see 6 whole square inches. Do you see my 6 holes? So I'm going to write 6 plus. Okay, what else do you see? 2 halves. What do we know about 2 halves? Okay, 2 halves equal a whole. So could I just do 6 plus 1 more? What would that be? 7. Our area is 7 square inches. Yes, we can multiply to find area, but we can also check that we're correct just by counting the amount of space inside our figure. So I'm going to put area equals, I'm going to label that, area equals 7 square inches. On Monday, we're going to come back to this same page and we're going to look and see how we could multiply those sides to get 7. But for right now, I just want you to understand that counting the square inches inside the rectangle also gives you the area. Okay, let's do another one. We're going to do one more since we don't have as much space on today's page. You can go down kind of towards the middle, near the bottom. I want this rectangle to measure 3.5 inches across the length again. So let's do 3.5 inches across the top. So remember, that's like 3 inches and then another 1/2 inch. Use your ruler. 3.5 inches long across the top. 3.5 inches, label. Down the width, let's make the width wider this time though. Let's make the width 2.5 inches. 2.5 inches. So that's like 2 inches and then another 1/2. 2.5. Two and a half inches wide. I'm going to use my ruler to connect the other sides. Remember, the bottom is also 3.5 inches. And then the other side is also 2.5 inches wide. You can shade this any color you wish. Again, to find area, yes, we could multiply the length times the width. But since we're just now starting to work with mixed numbers, I want to find area by counting the square inches that are inside my rectangle. I'm going to use my marker to label them as I count. First, I want you to label all the square inches that are 1 square inch. How many boxes or squares have 1 square inch in your rectangle? 6. Good. I just see 6 also. Now I see some other pieces. Let's start on the bottom. And I'm going to start on the left. What are these? Well, how many, I'm going to point with this. How many pieces like this would I have to put together to make a whole? 2 of them. So if it would take 2 of them, what would it be? This is a 1/2. Remember how the edge was 2.5? If this is my 2, this has to be my 1/2. So this is a 1/2. This is a 1/2. This is a 1/2. And that's a 1/4. Noah, how did you know that's a 1/4? Uh-huh.
And it kind of looks like it's like a box and a quarter. If you add 4 of those, then it would equal the whole box.
Okay, so I heard 2 explanations. I heard this small piece on the corner is 1/2 of a 1/2. What's 1/2 of a 1/2? A 1/4, okay. And then he also said, if you look at this small piece, it looks like it would take 4 of them to fill up that white square inch. So if it takes 4 of them, that means it's a 1/4. Now I have 2 pieces on the right hand side. What are these? Halves. Okay, so this is a 1/2 and this is a 1/2. Okay, so to find the area, we have to add all of these together. You could do it though. Let's use what we know about fractions. Let's start off with how many holes do you see? Okay, so I'm going to write 6. Now, do you see some pieces you can combine to make more holes? Rain? Put the halves together? Okay. I'm going to check them off as we combine them. So we've put this one, this one, this one, this, and this. We've added those. Okay. Ari, which ones do you want to combine? Ooh, that's a good strategy too. Ari's doing hers a little differently. She said, I'm going to convert all the halves to fourths and say 2/4 plus 2/4 plus 2/4 plus 2/4 plus 2/4 so that it will make adding her fourth easy. Go with it, Ari. I agree. I'm not going to do mine that way, but you go ahead and do it. That would work. Cole? There are only 5 halves. 1, 2, 3, 4, 5. So I'm going to kind of go to the side here. 5 halves is what mixed number? You're still keeping it an improper. You're keeping it an improper fraction. I want a mixed number. Like, is it 1.5? Is it 2.5? Is it 3.5? 2.5? So I'm going to say 6 wholes plus 2.5. Was anybody thinking this? And maybe you were. Was anybody thinking, well, I'll put these 2 halves together. Okay. And then I'll put these 2 halves together. Equals another whole. And then there's still half left. Oh, okay. Miami, you're adding the 1/4 and the 1/2. So can I just go ahead and put 1/4 on my sentence as well, plus a 4th? Okay. Ari?
So I was going to add all the halves to that, but then convert that half.
Okay, so you're saying take this half, the one that's left over, and change it to fourths. How many fourths are in a half? So 2/4. So it's kind of saying 6 plus 2 and 2/4 plus 1/4. And I just glanced over Adam. Adam, I love what you have too. Adam went ahead and did the 6 plus the 2. So he wrote 8.5 plus a 4th. Keely, do you have that? She's nodding at me. I bet she's got it too. So what's my whole number? 8. Okay. So what is a half plus a 4th? Okay. 6/8. Can you simplify it for me? 3/4. Our area is 8 3/4 square inches. Our area is 8 3/4 square inches. Now, you might be thinking, why are you making me do all this addition? Can't you just show me how to multiply it? I'm going to, I promise. On Monday, we're going to go back to this exact same page, and I'm going to show you how to do the multiplication. But here's the problem I might run into. If you're multiplying, you're not going to know that you're making a mistake unless you know how to check your work with addition. I want you to be able to look at that rectangle and see what the area is going to add up to. Then I'll show you how to multiply it. But until we can see that we can add that area up, I'm not really ready for us to multiply it yet. So I'm going to close out our journal video for today, and we're going to practice looking at some more rectangles and adding to find their area.